Hi class, welcome back to Sports Nutrition. The title of today's lecture is called Tools of a Healthy Diet. If you're following along in your textbook, you'll find part of this information in Chapter 1. However, just to let you know, I did compile a lot of these slides on my own, really to give all of you a foundation for how to think about nutrition in terms of planning a healthy diet, and also how to think about nutrition and nutrition recommendations when you're working with athletes. So I hope you enjoy this lecture. The objectives of this lecture today are to describe the dietary reference intakes and identify nutrient intake and energy intake recommendations, explain the daily values on nutrition labels and apply them in practice, identify the basics of the nutrition facts panel and name the top 8 allergens, and finally to compare and contrast how food pyramids have evolved since the early 1990s. So let's get started. I want to introduce to you the topic of dietary reference intakes, and I put a picture of the book here because when I think about the DRIs, it's really kind of like the textbook or the encyclopedia of nutrition. It contains 4 different sets of reference values that nutritionists and dietitians use when they're trying to help plan diets for healthy people and for athletes. So just to think of this in a normal way, it's really a standard used to assess and plan diets, and we'll go over those 4 reference values that it contains. And really it's a tool. It's designed to help plan and assess diets of healthy people. And finally, the amounts that are recommended for specific nutrients within the DRIs are really meant to promote good health, and we want people to consume these nutrients on average. It's really representing an average intake of these nutrients so that we can help prevent the incidence of chronic disease. So when I think about the dietary reference intakes, again, it's kind of like this umbrella term. It contains different sets of reference values within the DRIs. So think of the DRIs as like the overarching umbrella here. And underneath it, you have different sets of recommendations that are further subdivided. This picture, unfortunately, is not in your textbook. I took this from the Wardlaw's Perspectives in Nutrition textbook. So if you have that text, you can find that within that textbook. But otherwise, just look at this slide and hopefully you'll be okay. So within the DRIs, like I mentioned, you have 4 nutrient intake recommendations. These are referred to as the estimated average requirement, or the EAR, not the ear, but the EAR, the recommended dietary allowance, the RDA, an adequate intake, AI, or the tolerable upper intake level, the UL. On the right hand, you'll see that within the DRIs, we also have energy intake recommendations. So these energy intake recommendations, you have to think about them a little bit differently. They're pretty much broader, and they are useful when you're helping to think about a specific nutrient in the context of your total calories. So for example, we'll talk about the acceptable macronutrient distribution range. This is based on thinking about people's diets. Generally, let's say you consume 2,000 calories a day. What percentage of those calories should come from protein, carbohydrates, and fat? So those are a little bit different than the nutrient intake recommendations, which are pretty specific for nutrients such as fiber, calcium, vitamin D, iron, etc. So let's just go over some basic definitions because these are really important to know and it can be confusing, so I'm going to try to break them down as best as I can here. So one of the first reference values within the DRIs is known as the RDA, or the recommended dietary allowance. And this is simply defined as the average daily dietary intake that is sufficient to meet the nutrient requirement of nearly all, and when I say nearly all, that's almost 98% of healthy individuals in a particular group according to the stage of life and gender. I know that's a mouthful, but how I think about this is if you think about infants and toddlers, a pregnant woman, a lactating woman, or a healthy adult, all of those people have different nutrient needs. They're in a different life stage and age group. So someone who's pregnant or lactating has perhaps a higher need for certain nutrient, such as iron, compared to someone who is just a healthy adult and grown and not really, undergoing something physiological like growing a child. An infant and a toddler, they have different needs compared to a healthy adult. So when we think about the RDA, those are really set for different age groups. So hopefully that helps. An adequate intake, on the other hand, is a recommended intake value based on observed or experimentally determined approximations or estimates of nutrient intake by a group of healthy people that are assumed to be adequate. So where it gets tricky is, for a long time, the DRIs were strictly just based on the RDAs. Up until now, that's changed a little bit. Now, when we think about the DRIs, we think about these 4 different sets of reference values that I've already introduced to you. So when do we set an adequate intake? Well, when we don't have enough information to set an RDA. If you're thinking, who sets these DRIs? Is there like some high committee that does all this work? Yeah, actually there is. DRIs are usually set by an expert group of scientists who look at nutrition data collected over a long period of time. They form committees and subgroups and look at nutrient levels across the population and do their very best to set these recommendations. So hopefully that helps you put this into context. And it is published. It's available in the book form, which I had a picture of in the previous slide, or the easiest way is actually to go online and you could look at different tables. There's also a really nice table and appendix in your book that lists all the individual nutrients and the recommendations, whether that's an RDA, an AI, or something else. So what else do we have? So moving on, we went over those 2 first sets of reference values. Now we have the other 2. So the EAR, this is a daily nutrient intake value that's estimated to meet the requirements of half of the healthy individuals in a group according to life stage and gender. So I think about that as, you know, a nutrient intake value that's really covering the needs of about 50% of the population according to what life stage group you're in and gender, if you're a male or female. Then probably what's most interesting is that we have a tolerable upper intake level. So this is defined as the highest daily nutrient intake that's likely to pose no risk of adverse health effects for almost all individuals in a general population. As the intake increases above the UL, the potential risk of adverse effects increases. So why a tolerable upper intake level? Well, when I think about, I just call it a UL because that's much easier than saying this mouthful, but a UL really kind of protects you from toxicity states, right? As we'll learn later on in this semester, for certain vitamins and minerals, you can have too much. So a UL exists to say, hey, this is the highest amount, of this vitamin or mineral that you can safely consume. When you go above that, you better watch out because the risk of toxicity or some adverse effect increases. So that's why a UL really exists, is just to kind of give you that maximum amount of where you're safe. Once you go over that, you need to start considering that a toxic effect can happen. So this picture, again, I took from a different textbook, but I do like it because, you know, when you read those definitions, they are kind of confusing. So I think pictures sometimes speak much better to definitions, right? So this shows you the EAR, the RDA, and the UL. As I mentioned, the EAR basically covers the nutrition needs of 50% of the population. So you can see how that hump there is shaded 50% of the way. The RDA goes further, right? Because I told you that those numbers are set to really cover the nutrient needs of about 98% of the population. And then you have the UL. Look how far to the right the UL goes. That's pretty much showing you that the UL is set at a very, very high number, really to protect you, right? Because you can hit the UL, which is fine, but once you go above the UL, your risk for a toxic effect does increase. So I think that just helps put it into context a little bit better. Okay, so a little bit more on these 4 reference values, just to kind of sum it up. So remember, an EAR is used to evaluate nutrient intakes of populations. An adequate intake, on the other hand, recommends specific amounts of nutrients for individuals. When I think about an example of that, I think about fiber. So for fiber, there was not enough information, according to the scientific committee, to establish an RDA for fiber. So instead, what they did is they published an AI. So the AI for fiber is different for men and for women. For males, the AI for fiber is to consume about 38 grams per day of fiber. For women, it's about 25 grams per day for fiber. So that just kind of puts things into perspective a little bit more, and hopefully you're starting to understand where all of this falls and how that helps us when we are looking closely at our diets, and shed some light on how much of each nutrient we should be consuming each day. The RDA recommends specific amounts of nutrients for individuals. So if you look at the huge chart in your textbook right at the beginning, you'll see all the different numbers that are listed for different B vitamins, for folic acid, for certain minerals, and you'll see what your RDA is for each of those nutrients based on your age and gender. And then finally, we have the UL, and that really helps with the prevention of nutrient toxicities. We certainly don't want people to be over-consuming certain vitamins and minerals to the point where they're increasing the risk of toxicity. So kind of think of that as a safeguard. And then finally, we have those, not to forget about those 2 energy intake recommendations, right? I just talked about the 4 nutrient kind of specific recommendations. Now we have energy intake recommendations, and there's just 2 of them to know about. We have the EERs, or the estimated energy requirements, and this is useful because it can help it can be used to help calculate calories needed to ensure a stable weight and healthy individual. We'll get more into that later in this semester, especially when you're working with athletes. It's important to estimate their calorie needs, right? They're working hard. You want to at least have a baseline for how many calories they need every single day, and then add more calories to that EER based on their activity factor, right? Because they're exercising, they're obviously expending calories as they're practicing, working out, etc. So that's how we use the EER. The AMDR, last acronym I promise, is expressed as ranges or proportions of nutrients for healthy intake. And we have AMDRs for the 3 main macronutrients, which hopefully you guys know by now: carbohydrates, protein, and fat. So more on the AMDRs. I think, out of everything within the DRIs, this one makes the most sense to me. Even as a professor kind of standing here and lecturing you, this is really useful. And the AMDRs are established, again, by a bunch of scientists who work in the Food and Nutrition Board. That's a part of the Institute of Medicine and National Academy of Sciences. So a lot of smart scientists getting together to kind of figure all of this stuff out when we think about nutrition. And this is used to determine whether a percentage of each macronutrient falls within a suggested range. So what does that mean? The AMDR for carbohydrates is 45 to 65% of total calories. For fat, which is our other main macronutrient, it's 20 to 35% of total calories. And finally, for protein, it's 10 to 35% of total calories. So let's put this into context a little bit more now that I've given you kind of these broad ranges, right? So for example, the AMDR for fat, as I just told you, it's 20 to 35% of calories. So if you have someone who's on a daily diet of about 2,000 calories a day, how does that translate into calories? Well, if you took the low end of the AMDR, that 20%, you would take 20% of 2,000, and that's 400 calories per day from fat. If you took the higher range of that percentage of the AMDR for fat, 35% of 2,000 is 700 calories per day from fat. So that's really your range. And if you're wondering why a range, well, because people are different, right? The amount of fat I need is different from the amount of fat you need, and certainly different from the amount of fat an athlete needs. So that's why the Food and Nutrition Board said, hey, we're just going to establish a range and kind of cover all our bases. Now, if I gave you that on, let's say, your quiz or a practice problem for your case study this week, you should be able to translate those calorie amounts into actual gram amounts of fat, right? Because you just calculated the amount of calories coming from fat. So how do you do that? Remember from our previous lecture, fat, it's a macronutrient. It does give you energy in the form of calories, 9 calories per gram to be exact. So if I wanted you to figure out how many grams of fat, you simply take the 400 calories, divide it by 9, and that gives you 44 grams of fat. To take the higher end of that 700 calories, you divide that by 9, 78 grams of fat. So in totality, what do we have? The AMDR for fat, it's going to vary based on the individual, but you have a range here. It's 44 to 78 grams of fat per day based on a 2,000 calorie diet. Hopefully that makes sense, and I promise you'll practice this again in your weekly quiz. Okay, we'll move on here. So now we're kind of out of this DRI. So we've covered the 4 nutrient intake recommendations. We've talked about the 2 energy intake recommendations. Now I want to talk about something that's a little bit more practical and actually something you're seeing every day if you are looking at food labels on processed or packaged foods that you may purchase in a grocery store. So the daily values, this is present on food labels, and it's really a guide. That's how I think about the DV and how do I use it. It's really a guide to tell you about the amount of nutrients you're getting in one serving of food. So for example, if you had a nutrition label and let's say you were to look at calcium, you're interested in how much calcium you're getting from Chobani yogurt, let's say. It's telling you that you're getting 15% of the daily value for calcium. So that means that one serving of yogurt is giving you 15% of the calcium you need for the entire day. Putting that into context, the daily values again are based on a 2,000 calorie diet for healthy adults. For athletes, I kind of take that with a grain of salt, right? Because calorie needs for athletes can be higher or lower depending on whether they're in a hard training season or if they're in the off season. But general rule of thumb, 2,000, just to keep it easy, right? And daily values, the thing that's tricky about them is that if you actually looked at the numbers the daily values are based on, again, they're separated. They're a little bit different depending on what life stage group you're in. So there's daily values that have been set for infants and toddlers, pregnant or lactating women, and all people and adults over the age of 4. Luckily, most food labels we see out there, the DVs are set for people over the age of 4 because that's most of the food that's out in the grocery stores, right? Most of us are over the age of 4, so the daily values are certainly based on that life stage group. The highs and lows of daily values. So this is interesting to me because, again, just reinforcing that daily values or percent daily values are for the entire day, not just one meal or snack. And for some nutrients, people often ask me, well, do I need more or less? If I see a higher percentage for a daily value, is that good for that nutrient or should it be low? I kind of like to think of it as a food budget, right? So, for most nutrients, you want to hit 100%, especially for short, full nutrients that we're not getting enough of in the American diet, like calcium, vitamin D, potassium, fiber, etc. However, for some nutrients that we've kind of understood from science that maybe some of these nutrients are harmful for health, you want to aim lower when you're looking at food labels. So what do you want more of in your diet, right? So if you're looking at this little iteration here on your slide, when you're looking at food labels, things you want to look for in terms of high on the daily value, which is defined as 20% or more, most of your vitamins, minerals, and fiber. So as I mentioned, look for high daily values for calcium, vitamin D, fiber, etc. Where do you want to look for low for a daily value? Well, low is technically defined as 5% or less. You want to aim low for nutrients like saturated fat, trans fat, cholesterol, and sodium. Why is that? Well, we know again from scientific research that some of these nutrients are linked to adverse health conditions like heart disease or pretty much anything else. So certainly you want to aim low for that. Again, for an athlete, it's always a little bit different. So for an example, for an athlete, I may recommend that they actually get more sodium and aim for a higher daily value because they're sweating a lot. And a lot of the sodium is coming out in their sweat, so they need to actually replenish that. So again, everything you need to take in the context of an athlete versus a healthy person. But generally speaking, this is what I want you guys to know for right now before we get really specific with athletes. This is another example of how to put the daily values into practice. So my favorite types, chips, sun chips, I don't eat these all the time, but I do happen to like these really much, the flavor, right? So if I turn this over and I'm looking at the nutrition facts panel, again, this is where you would find your daily values. It's always going to be in the right-hand upper corner, and it's going to say percent DV, right? So here you can see that for 1 ounce, the serving size on this bag of chips is 1 ounce. So for about 15 chips, the fat, basically DV, is about 10%. So I'm getting 10% of the daily value for fat by eating about 15 chips, right? So I don't have to eat a lot of chips to get some fat here. But basically, what did I just tell you? That fat and saturated fat especially are some of those things that you want to aim for as low. So ideally, if you're someone who's health conscious and looking at food labels, you want this to be less than 5%. So how else can you use daily values to determine how a food fits into your overall diet? This is just another example here. So if you like cooking frozen meatballs, right? Quick, easy meal, you just thaw them out and add some sauce and boil some spaghetti, you have dinner, right? But you're curious and learning what nutrients you're getting from about 6 meatballs, which is 1 serving here. So for fat, you can see that 1 serving or 6 meatballs is giving you 11% of the daily value for fat. How do you interpret that? Well, again, I think about it as like a food budget, right? Everything should add up to 100. So you can interpret it as you've used 11% of your fat allowance for the day by eating about 6 of these meatballs or 1 serving. And then you could flip that around and take that, subtract 11 from 100 and say you still have 89% of your fat allowance left for the day. So that's how I like to think about it. But again, remember fat, saturated fat especially, one of those things that we kind of want to aim lower for. So if that doesn't add up to 100 for fat, not a huge deal. You should be aiming a little bit lower. We'll move on because I want to teach you guys about the basics of a nutrition facts panel. I actually think this is really important because we all consume food, we all buy food. And hopefully we're all looking at food labels because they give you all the information you need if you're really curious about what you're getting in terms of nutrients from your food. So there's about 8 different things that are listed on this slide that I really expect you to know. The first thing you'll find on the food label is the serving size and the servings per container. Usually that's one of the first things listed in the upper half of the nutrition label. You'll also find the percent daily values, as I've just alluded to you. Then you'll see all the specific nutrients that are listed and how much of that nutrient is in 1 serving of food or a beverage or whatever you just purchased. So you'll see total calories are listed, calories from fat, total fat, saturated fat, cholesterol, etc. All these nutrients are listed on food labels. Nutrient claims, so we'll talk specifically about claims. Most often you actually see this on the front of package, right? So if you buy oatmeal, plain old Quaker oats, there's a claim for oatmeal. It says oats can help reduce cholesterol, right? So that's actually a health claim or a type of nutrient claim. And again, you'll find that on the front of the package. You will see the ingredients listed on the nutrition facts panel, and ingredients are listed in descending order by weight. So what does that mean? Well, if I just bought a box of Chex, one of the first ingredients that's listed may be wheat or something like that, right? And one of the last ingredients listed is probably some kind of vitamin or mineral because they fortify cereals. So the ingredient listed first is present in the most amount, and the ingredient listed last is kind of the least present in that item that you're eating. Other things that are required to be on nutrition facts labels or panels is the name and address of manufacturer. So consumers definitely have the right to know where their food was made, and if they have any comments, questions, or concerns about the product. There's also usually a phone number that's listed. Consumers can dial in and ask questions about the product if they're concerned about anything at all. And finally, and what I think is probably most important on this slide, is allergens. So food allergens are a big deal these days. People are allergic to so many things beyond what's listed on this slide. But what we've done here is kind of come up with a top 8, right? So there's 8 major allergens that are usually present in food or in food manufacturing plants that are required to be on the label. So milk, eggs, fish, shellfish, peanuts, tree nuts, wheat, and soy are the 8 allergens that are required to be listed. What happens if you're allergic to something else that's not one of the top 8, like apples or celery or anything else for that matter? Well, it's kind of up to you to look at the ingredient list and identify anything in there that would be labeled as apple or celery. And if you're not sure, that's where contacting the manufacturer really counts, because you do not want to end up with an allergic reaction, or if you have an insensitivity, end up with some kind of GI distress. So please make sure you're looking for this information when you're purchasing food. This picture is from a different textbook. It's from actually the Wardlaw's Perspectives in Nutrition textbook, and one of the first couple chapters. And I like it because it basically reiterates everything that I just told you. It shows you exactly where you can find this information, but I've summed it up for you on the previous slide. So again, just showing you this because it really kind of breaks down the front of the package, showing you right in front by the micromac. You can see that nutrient claim, good source of calcium, followed by kind of breaking down the nutrition facts label and showing you where you can find everything else. We'll move into claims a little bit more because I think this is important because, I'm not just a nutrition professor, I'm also a consumer myself. So when I go grocery shopping, I look for claims on food packages because I'm curious to know what this product contains or what it can do for me, right? So one of the first types of claims that you'll find on food packages are nutrient content claims. And nutrient content claims are probably the most common type of claim that food manufacturers will make on a package because it simply just describes the nutrients in this food. So examples of nutrient content claims could be low in fat, rich in vitamin A, good source of fiber, good source of calcium, etc. Any of those are nutrient content claims. And you can see on this Ritz cracker box that we have a nutrient content claim. It says low sodium. So hopefully now you understand that basically all it's saying is that these Ritz crackers are low in sodium, and that's an example of a nutrient content claim. Structure function claims are probably the second most common type of claim we find on on food packages. And all this really does is describes how a nutrient affects human body structure or function. So where would you find this? Probably if you were buying something like a dairy food, yogurt or milk or any kind of smoothie or shake. One of the most common structure function claims is calcium helps build strong bones. And we know that calcium is a mineral we need in our diets every single day, and it's all it's telling you is calcium, it's a nutrient, and it's doing something for your body. There's a structure and function to bones, so that's how these two relate. Third type of claim that's really common are health claims. So this describes a relationship between a disease and nutrient or food. So my Quaker Oats example, oatmeal helps reduce cholesterol. That's a perfect example of a health claim. There are others that exist on food packages, but this one is really common. I advise that health claims are a little bit different than nutrient content and structure function claims in that you actually need some research and science to back these claims up. Food manufacturers do not have the liberty just to put whatever they want on the front of pack to sell products. This actually has to be substantiated by science. So if you are doubting a content claim, or I'm sorry, a health claim, you can certainly go to the food manufacturer's website. You can look at a specific product online. They may even cite or reference the research they have to back up this claim. They don't have to disclose that information, but certainly they need to know internally that they back that claim up by science. Otherwise, they can get in a lot of trouble by the Food and Drug Administration or the Federal Trade Commission, which is the FTC. Finally, we have the qualified health claim, and this one I kind of have on the bottom for a reason. There's not too many of them that are out there on food products. They're extremely hard to get. And usually the science that is available to back these types of claims up is really limited. So I probably won't even test you guys on this because, again, these are really difficult to find on food packages. And if I find a good example of a qualified health claim, I'll be sure to post that on Moodle. But for now, hopefully you understand the differences in these four types of claims. We'll move a little bit now into nutrition recommendations. We've talked about the DRIs and nutrient intake and energy intake recommendations. We've talked about food labels and how to kind of apply that in practice. But I want everyone to understand, where does nutrition policy live and where do recommendations come from? And really they come from the Dietary Guidelines for Americans. The Dietary Guidelines for Americans are basically a set of diet and lifestyle recommendations that are designed to promote health and reduce risk of chronic disease. These recommendations are actually updated and published every 5 years. So in 2015, the latest recommendations were published, and those will be good for the next 5 years. I know we're already in 2017, but these will be good until 2020. And then in 2020, there's going to be a new set of dietary guidelines that are released. And these are actually pretty useful. I'll post a link to Moodle where you can actually read through this very long document. I won't make you read through everything. I'll point out kind of the highlights here. But they basically translate all the nutrition science that is out there into key recommendations for the public. So trying to make the general public understand what foods we need more of in our diet, what foods we need less of, staying active, physical activity, all these recommendations kind of fall under the umbrella of the dietary guidelines. So what I've done here is I've actually gone through the guidelines myself. Like I said, it's a huge document. It's over 100 pages, but I want you guys to know the basics, right? So what these scientists have done is evaluated all the nutrition literature and kind of looked at the key takeaways and published those. So that way we can translate this to the public. So some of the main messages are on this slide here. It's consuming a healthy eating pattern that accounts for all foods and beverages with an appropriate calorie level. And what does a healthy eating pattern include? Well, a variety of vegetables from all the vegetable subgroups, fruits, especially whole fruits, grains, at least half of which are whole grains, fat-free or low-fat dairy products, a variety of protein foods, and these protein foods can be plant-based proteins or animal-based proteins, and finally oils. So all of these different types of foods fit into a healthy eating pattern. What else did the 2015 dietary guidelines tell us? Well, a healthy eating pattern includes some of the things I just told you, but it also limits some things. And these are saturated and trans fats, added sugars and sodium, and some other things here that are really specific to the public. We should consume less than 10% of calories each day from added sugars. We find added sugars in fruit juices, beverages, cookies, cakes, anything pretty much that has been added to food during processing is considered an added sugar. I can spend a whole other lecture on that topic. That's actually really controversial, but certainly the definition of added sugars is kind of confusing, but this is on a basic level. Consume less than 10% of calories each day from saturated fat. Consume less than 2,300 milligrams of sodium each day. And if you are consuming alcohol, it should be done so in moderation, meaning 1 drink per day for women, 2 drinks per day for men. Of course, you should be of legal drinking age. So that's what some of the main messages from the dietary guidelines tell us. So we're going to take a kind of a dip back in time. And how did nutrition kind of policy and recommendations and guidance evolve? Well, it had to start somewhere, right? And I'm sure it started way before the 90s, but this is kind of what I remember when I went to college and was first learning about nutrition, and what are the pictures that we put out to the public to better understand what our diets should look like. Well, this is one of the first kind of pictorial models that was developed in 1992. We started with this food guide pyramid, and the purpose of this is really to kind of just give you a visual for what your diet should look like, right? So what you can see at this pyramid at the very bottom or the base, that you should be getting 6 to 11 servings of bread, cereal, rice, pasta, basically. All of those kind of fit into the larger umbrella of carbohydrates. Then if you kind of look in the middle layer, you should get 2 to 4 servings of fruit and 3 to 5 servings of vegetables. Keep going up, you should get 2 to 3 servings of milk, yogurt, similar amounts for your lean protein, meat, poultry, fish, etc. And then at the very top, keeping things like fats, oils, sweets, anything else to pretty much keep it sparse in your diet. So this is one of the first ones we saw in the public at that time. They evolved, so it was a long time until that picture changed. So you can see here in 2005, it took them all that time to change this picture. They updated the food pyramid to something called My Pyramid. So you can see how very different this looks. In my opinion, this is perhaps a little bit confusing, but what it's supposed to do is encourage physical activity. So now we see this man or woman or person kind of walking up the steps of the pyramid to encourage physical activity. And then we see our food groups and how much of that we should be consuming every single day. So you see similar food groups, grains, veggies, fruits, milk, and kind of your protein on the far right. But what's really confusing is that within that pyramid, you're not sure how much of each food group you should be getting. That was one of the major limitations, I think, to this model in 2005. And today, or I should say, based on 2011, which is the latest and maybe greatest picture that we have, it changed again. There is a lot of controversy and basically criticism to the 2005 pyramid, so they changed it, and now we have Choose My Plate. This picture still exists, so it's the best we have today for public nutrition guidance. And I think the thinking here was, we eat on a plate, or at least most of the time, and people kind of get this a little bit better than a pyramid, right? So instead of showing a pyramid and how much of each food group we should be getting in terms of servings, we're going to show it on a plate in a simpler form. So you see this round plate, and it's divided out your food groups to show you how much of each food group you need and each time you eat. So for grains and protein, you can see that's about 1/4 of your plate. Vegetables, it's a little bit more than 1/4, and fruits a little bit less than 1/4. And then you have dairy on the side. I want you to think about this a little bit and think to yourself, well, what are the advantages to this plate? What are some of the limitations, right? To me, you know, this is an improvement from the pyramid, but it's still not specific enough because the general public may not even know, well, what counts for protein? They may not know that chicken, eggs, dairy, plant-based proteins like beans count for protein, right? Some people would argue, well, I still don't know how much, you know, how am I supposed to gather that my plate should be less than 1/4 of fruit, or what's 1 serving of fruit? It can be very confusing, but needless to say, this is the best we have today. So a little bit more on my plate. Why do these pictures exist? Well, really they correspond with the dietary guidelines for Americans that I introduced to you today. And it's kind of a way to take dietary guidelines and translate it a little bit simpler to the public. Most consumers and people like us don't spend half of our day reading a 100-page document. So the idea of having a picture that shows you how you should be eating is just a little bit easier. I've listed the website here. Maybe some of you visited already. It's choosemyplate.gov. I encourage you to check it out. You'll see some quiz questions come from there on the basic level, but I think it does have some nice resources and tools to play around with if you're interested in learning more. Okay, we'll talk a little bit on serving sizes and kind of what counts as a serving, because I think, you know, the general public doesn't know. Every time we go out to eat, you know, oftentimes our portions are distorted. We get too much, or if you're going to a fancy restaurant, sometimes you're getting too little. So how much is what you should be getting? So I've put this chart here basically for you to look at as a guide. And this comes again from the Word Laws and Perspectives textbook. If you don't have that book, no problem. I'll put a skeleton copy of these notes on Moodle so you can walk through this. To me, I think it's much easier actually, instead of, you know, thinking about things in cups or other kinds of portions, it's really just to use standard size objects, because I think people get that, right? So if I tell someone have just 2 tablespoons of salad dressing on your salad, most people don't measure that out. But if they thought about a golf ball or the size of the golf ball, that's a better indicator for how much dressing you should be putting on your salad. Certainly you don't want to put a baseball size of salad dressing on your salad. 2 tablespoons is just enough. If you're thinking about other things in terms of a bagel, an English muffin, or a baked potato, I like to use the tennis ball analogy. That's 1 serving for any of those foods. For protein foods, things like meat, fish, chicken, it's a deck of cards, and a deck of cards pretty much is equivalent to about 3 ounces. I also like using the palm of my hand. So without your fingers, if you just look at your palm, that's about 3 ounces or a serving of protein. And then finally, when you think about something like 1 cup, I like to use the baseball analogy, and that could be 1 cup of anything, or it could be a larger piece of fruit, large apple or orange, or it could be 1 cup of ready-to-eat breakfast cereal. So that's all I have today. Thank you so much for listening, and I really hope you enjoyed this lecture. Take care. Bye-bye.